All right, hi everybody. I want to briefly give you an overview of the program that you're going to be using for the Newton's second law simulation. Newton's second law relates force, mass, and acceleration with one easy to use equation that basically lets you, predict how motion changes when forces are unbalanced. To get to the simulation, I'm going to pull up the internet and I'm going to type in PhET, force and motion basics. You want force and motion basics. I will click on the first link. I will push the play button in the middle of the screen. It might take a second to load. And I'm going to go to acceleration, and it will bring me here. The first thing I want to do here is I want to make sure I can see everything. So I want to check all the boxes so I can see speed, acceleration, forces, all of that. Just so we are aware, the sum of forces here, this is the same thing as the net force. The sum of forces and the net force are the same thing. And there's definitely going to be times where you're going to be recording this number. Looking around here, we have various objects of different masses, right? So if Newton's second law relates force, mass, and acceleration, we basically want to look at, how different masses react to the same amount of force. And likewise, we're going to look at how different amounts of force will affect the same mass. So I can, swap things out if I want to, instead of the 50 kilogram crate, I could use like the 200 kilogram refrigerator. If I wanted my object to be like 150 kilograms, I could like put the bucket of water on top of the crate if I wanted to. And these two things now will move together as a 150 kilogram object. Other than that, force values are given down here. I would recommend using these arrows on the inside and using pretty numbers. Every time you use these arrows, it's going to increase the force by a factor of 50. And the more pretty numbers you have here, the easier things are going to be. So I would encourage the applied force value to be some type of, pretty number like a 50, a 25, a 100. Like those numbers tend to give easy to understand values. So please keep your numbers pretty. I mean, I also could, slide this like so, but that can get a little, it's like if I want 225, it's a little tricky. So I would encourage you to just use these double arrows to make everything nice. And if things go wrong, you can always just hit the reset button. When you hit the reset button, please just remember to, select everything so we have all of our values. Let's look now at part one. Part one is going to be frictionless, meaning that I want to take this slider and drag it all the way over to none, and you will know that it is all the way over because the surface becomes ice. So when the surface is ice, you are good to go for part one. What we're going to do here is we are going to look at different forces, different masses, and see what the resulting acceleration is. Some are given, and then all the rows in your table that are blank, you are going to make up values. And once again, I would encourage you to use pretty values. So I'll put the force up, 50 kilograms, 100 newtons of force. And we clearly have acceleration. We see that here, and we see that because the speed is going up. When I am here and the acceleration is stable, I'm going to press pause. I'm going to press pause to stop. I'm going to record my values like this. The reason why I am encouraging you to do that is because because as this accelerates, it's going to continuously gain speed. This program does not let the object gain speed forever. Once the speed hits 40, the force stops being applied. So if we watch the speed rise, once it hits 40, the crash test dummy stops pushing it, and therefore the force goes down to 0, and the acceleration also goes down to 0. And that's not going to be very exciting data. So please make sure that you can pause and record your values prior to the speed reaching 40 and the guy letting go. Now we can just, reset. If we reset, please make sure that you bring the friction back to 0 and make all the values visible. And you can take it into the trial. And then that's how we're going to do part one. All right, last part, this is part two. So part two is going to be friction, and part two is a little harder to get pretty numbers, and I want to kind of show you how we do this. So first of all, for part two, we are going to remove the friction slider up somewhere so we have some friction, and we're probably going to be changing this a little bit. I'm going to make up, I don't know, let's do 150 newtons of force. And we see, you know, I got 150 newtons of force, 66 newtons of friction, which is giving me a net force of 84 newtons. Not the prettiest number in the world. So what I would recommend doing is pausing the simulation like I did. And I'm actually going to fiddle with this until I can get the net force to a pretty number. So if I drag the friction slider, now I have 150 newtons of applied force, 50 newtons of friction, and 100 newtons worth of net force. However, this is not yet correct. I need to push the play button and everything's going to kind of normalize. So I'm going to push the play button and this acceleration value is going to change. So I'll push play, the acceleration button's value is going to change. Now I can pause it again. Now I can take my measurement. For the next one, you have a couple options. You know, you can always change the force. You also can change the friction. Please, 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 you know, do a little bit of both, right? I can, you know, I could bump the force up to, I don't know, let's go to 400. You know, I could take a measurement like that. Likewise, I also could drag this one over here, you know, and give it a little more friction. Something like that if I wanted to. Once again, I need to press play to kind of let everything normalize. Now I could take a value. So I just wanted to show you folks, I want to show you folks the technique I use to get pretty numbers and just remind you that we are dealing with friction in part 2. Please look at a variety of different friction values. Awesome. Great. Let me know if you have any questions and